Now let us build an example program for do-while loop. stdio.h, I'm including the header file. Coming to the main function, int I equals 1. Do, starting of do-while loop. In braces, printf \n, the iteration number is %d, I. This prints the value. I equals I plus 1. I'm incrementing I value by 1. After brace, while I less than 5. This is my do-while loop to check the condition. Brace close. When I execute this program, the output will be the iteration number is 0, the iteration number is 1, the iteration number is 2, the iteration number is 3, the iteration number is 4. Let us see another example program for do-while loop to print odd numbers. stdio.h, I'm including the header file. Coming to the main function, I'm declaring the variable int I, and I'm initializing I to 1, that is I equal to 1. Do, this is starting of my do-while loop. Printf \n %d I, this prints the value. I equals I plus 2. I'm incrementing the I value to 2. After the brace, while I less than equal to 20. This is my do-while loop check condition. Brace close. When I execute this program, I get 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Let us move on to the for statement. We also use the keyword for to implement loop operations. The general form for for statement is for, in parenthesis, initialization, semicolon, test condition, semicolon, update. Following brace, statement, brace close, and then rest of the program statements follow. Example, for, in parenthesis, I equals 0, semicolon, I is less than or equal to 100, semicolon, I plus plus. Brace statements, brace close. You can see the flow chart on the screen. In the above loop, we initialize I with value 0, and in the next part, I is less than equal to 100, we check the loop condition, and in the final section, we increment I value by 1. Iterative constructs the for loop. The for loop construct is by far the most powerful and compact of all the loop constructs provided by C. This loop keeps all loop control statements on top of the loop, thus making it visible to the programmer. The for loop works well where the number of iterations of the loop is known before the loop is entered into. Iterative constructs the for loop. The header of the loop consists of 3 parts separated by semicolons. The first part is executed before the loop is entered. This is usually the initialization of the loop variable. The second is a test. The loop is terminated when this test returns a false. The third part is a statement to be run every time the loop body is completed. This is usually an increment of the loop counter. iterative constructs the for loop. Let us take an example. stdio.h. This is the header file. Coming to main function, int I, this is the variable, for I equals 0, semicolon, I less than equal to 9, semicolon, I equals I plus 1. This is my for loop. It executes if I is less than 9 is true only. Then printf %d I. This prints the value. I'm closing the braces. This is end of my for loop. And then increment the I value by 1. I'm closing the brace. When I execute this program, I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us take an example for loop displaying the multiplication table. stdio.h, the header file I'm including. Coming to the main function, int n equals 2, int I. For loop, I equals 1, I is less than equals 10, I equals I plus 1. For loop is executed if I is less than or equal to 10, if this condition is true only. In brace, printf %d capital X %d equals %d n I n into I. This prints the message. I'm closing the brace. This is end of my for loop, and increment the value 1 by 1. Brace close. When I execute this program, I get 2 into 1 equals 2, 2 into 2 equals 4, 2 into 3 equals 6, 2 into 4 equals 8, 2 into 5 equals 10, 2 into 6 equals 12, 2 into 7 equals 14, 2 into 8 equals 16, 2 into 9 equals 18, 2 into 10